Let's talk about temperature, pressure, and volume units. Most of us are comfortable with measuring temperature in degree Fahrenheit. However, when working in science, we typically use degrees Celsius. For this unit, however, when we're dealing with gases, we have to be comfortable using the Kelvin scale. Now please note that it is degree Fahrenheit, so you have the degree symbol. It's degree Celsius, so you have a degree symbol. But with the Kelvin scale, there is no degree when you are recording a temperature. Now, as a review, we know that the melting point and the freezing point of water is 32 degrees Fahrenheit, which is the same thing as 0 degrees Celsius. And the Kelvin scale is 273 K. The boiling point and condensation point is 212 degrees Fahrenheit, whereas in degrees Celsius, it's 100 degrees Celsius. And in the Kelvin scale, it is 373 K. Again, we do not use degree Fahrenheit in a typical science class. We do like to use both degrees Celsius and Kelvin in science, and we usually use Kelvin when working with gases, but we can see it in other topics as well. Why we use Kelvin instead of degrees Celsius when working with gases is for 3 reasons, or 4 reasons actually. The first reason is 0 degrees Celsius, the freezing point of water, is a common value. So when we multiply by 0, our answer is automatically 0. So having a 0 degrees Celsius just negates everything and leads to a false answer. Negative temperatures or negative numbers are common in the degrees Celsius. So for example, 5 below degrees Celsius is common. So when we multiply by a negative number, our answer is automatically negative. If we use the Kelvin scale, 0 K, the lowest possible temperature on the Kelvin scale is 0 K, is called absolute zero. This is when all movement of atoms and molecules does not exist. It's very, very difficult to reach absolute zero, so we don't have to worry about 0 K. And when we use the Kelvin scale, there's no negative values because the lowest value is 0. So our 4 units that we're going to focus on are going to be pressure, volume, temperature, and the mole. We're going to use the letter N to represent the mole in future equations. We know that we can't use degrees Celsius because we can't have a negative temperature. When we multiply by a negative, the answer is negative. So we know that we can't have a negative pressure or a negative volume or a negative mole. We can have a 0 pressure, a 0 volume, or a 0 mole, but we can never have a negative. But if T is equal to 0, then what I'm looking for automatically becomes 0, which isn't going to be true. Okay? Just because my temperature is 0 degrees doesn't mean that my pressure is automatically 0 or my volume is automatically 0. Okay? So what we do is we have to be able to convert from degrees Celsius into the Kelvin scale. So we have a formula that Kelvin is equal to degrees Celsius plus 273. So my range for Kelvin here is going to be 0 Kelvin to some positive number. That means that the lowest possible value that degrees Celsius can be is minus 273. So minus 273 plus 273 means that you would have a 0 Kelvin, absolute 0. We also need to be able to solve for degrees Celsius. So instead of adding 273, we are going to subtract 273 from K. So in this typical range, the lowest temperature is 0 Kelvin. And 0 Kelvin then would mean that my degrees Celsius lowest temperature would be minus 273. Okay. So minus 273 to a very, very positive number. So let's look at an example here. Temperature conversions. So if I wanted you to go from 25 degrees Celsius to Kelvin, I'm going to use this formula here, and I'm going to replace 25 and for degrees Celsius, 25 plus 273, I add that together, and that's going to give me an answer of 298. So that is 298 K. 130 degrees Celsius, I add 130 plus 273. That gives me an answer of 403 when I add it together. So I have 403 K. You give number 3 a whirl. Minus 85. So my degrees Celsius is a negative 85. A negative 85 plus 273, when I add it together, gives me a value of 188 K. I need to be able to go from Kelvin into degrees Celsius, so I have to rearrange this formula for degrees Celsius. So that means I have to subtract 273 to get my value. So my K value here is 465. 465 minus 273, when I do this on the calculator, it gives me 192 degrees Celsius. And then if you try here, if I give you 175 K, 175 minus 273 is going to give me a negative degrees Celsius. It's going to give me negative 98 degrees, and it's okay for degrees Celsius to be a negative number. So moving on, we need to be able to talk about other units. Let's talk about pressure. Pressure is basically taking the force and dividing it by a surface area. So think about taking your writing utensil and putting the eraser end in the palm of your hand. Apply a force down, so press down into your palm of your hand, and you can feel the pressure. Now, if you flip your writing utensil over so that the pencil lead end is in the palm of your hand, would you want to apply the same force? And the answer to that is no, because it's going to hurt. Your force is going to stay the same, but my surface area got much, much smaller. So when my denominator becomes smaller, that means that my pressure goes up. So as force increases and the surface area decreases, the pressure goes up. That's an indirectly proportional statement. As one goes up and the other goes down, that's an inverse proportional statement. Now, if we decrease the force and we increase the surface area, then the pressure would go down. We use units to measure pressure. We're not really familiar with these pressure units because when we look at our weather channel, they usually give it to us in inches of mercury, but we don't want to use inches in science. So we're going to use ATM, which is atmospheres, the torr, which is not a shorthand, it's just a torr. And then we have mmHg. mm is my millimeters, and Hg is the symbol for mercury, so millimeters of mercury. And then kPa, which stands for kilopascal. Now, we'll use atmospheres, torrs, and millimeters of mercury in our class. If you take physics, you'll use kilopascal and pascal. So I have a couple of practice problems just using the kPa, just so if you don't take physics, you have a couple of examples. Now, a torr and a millimeter of mercury are interchangeable. That basically means that a torr and the millimeter mercury are the same. So if I give you a problem that says torr and another unit that says millimeters of mercury, you can either use them both as torrs or you can use them both as millimeters of mercury. The atmosphere is always set equal to 1. So just like when we talk about a mole, the mole is always set equal to 1. When you're dealing with atmosphere, the atmosphere is always set equal to 1. 1 atmosphere is the pressure at sea level. Now, there is a relationship between atmospheres and torrs, atmospheres and millimeters of mercury, and atmospheres and kPa. So again, 1 ATM is equal to 760 torr, 1 ATM is equal to 760 millimeters of mercury. Remember that torr and millimeters of mercury are basically the same thing. torr is just a unit that we use to name after the scientist who worked with pressure. And we use millimeters of mercury because just like a thermometer, we put mercury in we used something called a U tube. And so it was a tube in the shape of U, and we watched the mercury rise and fall so many millimeters. All right, so let's look at some conversion problems. I have these 3 conversions written for us up at the top. We just have to choose which one we want to use. So I'm going to give 2.5 ATMs, and I want to convert it to torr. So I bring down my 2.5 ATMs. I have to put the ATM in the denominator so the ATMs cancel, and I have to put torr in the numerator. And I now look for my conversion that has ATM and torr, and here it is. So the ATM is always set equal to 1, and my torr is 760. So I'm going to take 2.5 and multiply it by 760. I only need 2 sig figs, and when I plug and chug, I get 1900 torr. I can go the reverse direction, torr to ATMs. I take my 1100 torr, I put torr in the denominator, ATM in the numerator. I look for my conversion between those. Again, the ATM is set equal to 1, and we have 760 torr. So here we're going to take 1100 and divide it by 760, put it in my calculator, and it will say 1.4. 2 sig figs, 1.4 ATMs. Here's an example with KPA to ATMs. I'm going to take 350 KPA, put KPA in the denominator, ATM in the numerator. I'm going to look for my conversion. ATM is automatically set equal to 1, and my KPA value is 101.3. So I'm going to divide these 2 numbers together, 2 sig figs, and my calculator answer is 3.5 ATMs. All right, so my last 2 practice problems here are going from millimeters of mercury to ATMs, or ATMs to millimeters of mercury. So bringing down my 400 millimeters of mercury go in the denominator to cancel. I'm going to ATMs. I'm finding my conversion between ATMs and millimeters of mercury. The ATM is set equal to 1, and my millimeters of mercury is 760. I'm going to divide these 2 things. 400 divided by 760. I only have 1 sig fig, so my calculator is 0.5 ATM. And then 1.65 ATMs into millimeters of mercury. My ATM goes in the denominator. Using my conversion, again, the ATM is set equal to 1, and my millimeters of mercury is 760. I'm going to multiply that out. I need 3 sig figs, so that is 1250 millimeters of mercury. Right. So conversions are just being able to find the correct conversion and go from there. Now, what I would like to do is just talk about some units here for just a second. Temperature, remember, is going to be in degrees Celsius or Kelvin. We will want to convert our problems into kelvins. So Kelvin is equal to the degrees Celsius plus 273. Pressure can be in ATMs, millimeters of mercury, or torr. It doesn't have to be in one of them more than the other. It just depends on how the problem reads. So if we look at our conversion, if we have to go into one of these, please make sure that you know the conversion, okay, to be able to swap out. And volume is going to be another unit or another variable we're going to work with, and the problem can be given to you in liters, milliliters, or cubic centimeters. And depending on the question, you may have to change it into one of these 3 units. So from a recall, 1 liter is equal to 1,000 milliliters, and 1 milliliter is the same thing as 1 cubic centimeter.